And so what functions really just comes down to we're all human, right? And we have a limited amount of working memory. If you think about like phone numbers, right? So there are 10 digits, and 10 random digits is pretty hard to remember. But if we chunk it into an area code and a prefix, and then the last four, then it's more graspable for our minds to memorize and to utilize. And so functions are very similar in that. So instead of having to keep, dozens or hundreds or potentially even millions of lines of code all in your head and understanding how they relate to each other, that's just going to be way too much. So by chunking it into these tiny little pieces, we can handle it a lot better. And we've already been doing that, right? Like use the print function all the time for the last couple days. And that is a function, and it has probably many lines of implementation, but you don't have to think about those. You just use the print function and you count on it working. So now we're going to look at like, well, what if you wanted to make your own function, right? Python has probably hundreds, I don't know if it has thousands, but certainly hundreds of functions that are just built in, and that's great. But eventually you're going to get to the point where there is no built-in function that does exactly what you need. So we're going to look at building our own. So to do that, we start out with the keyword DEF, which is short for define. And then we need to give it a function name. So we're going to do print greeting. So the rules for the function name are the same as for variables. And it's really not, in my experience, worth memorizing all the rules for those. It's better to just try the name you want. And if you get the error, you look and you see that it's like an illegal name error, and then you can correct it and do something that is not violating the rules. And then, so after we have our function name, we need to have parentheses. Those are always required, even if they're empty. And in our case right now, it's going to be empty. And then the final thing is you need a colon to finish off your opening of your function statement. And then, so if I did everything correct and I hit return, Jupyter should be kind enough to indent for me, right? So I didn't have to put in 4 spaces manually. The Jupyter does that for us. And then we need the actual code that's going to happen inside of our function. And for right now, we're just going to do a print hello statement. And then I'll add one more just to show you that, it's not just, same in like the if statement, you can have multiple lines here. And so, or you. All right. And so now I'm going to run this cell and nothing's going to happen. But something actually did happen, just nothing visible happened. So now there is this thing in memory that is my print function that I can call by name anytime I need to use it. So to call it out, I use its name. Yeah, so print greeting. And I need to include my empty parentheses as part of my call. So now if I run this cell, then I'll get the output from it. So let's have everyone do that real quick and just put up a green check mark to let us know that you successfully created a function and was able to run it. And if there are any questions, let us know. And I have a very limited screen real estate today, so if the helpers could call out questions from the chat, I would appreciate it.
I'm seeing a lot of check marks coming up. over 10 so far.
That's good. All right. And we'll go ahead and move to the next phase. So we need to do our arguments. So like if we don't always want to just have empty parentheses, we're going to need to have functions that are able to take in information and then process that within itself. So let's do another function. So we start with DEF and it shows up green to let us know it's a keyword. And so we're going to do print underscore date and then open parentheses. But now we're not going to have it be empty. We're going to do 3 inputs to it. So, and they're going to be called year, month, and then day. And then we still need our closing parentheses and our closing, or not closing, but it's the end of our declaration is a colon. And so if I hit return, it indents for me. And then so we'll have 2 lines of code in this function. And so first we'll use a line of code to concatenate together those 3 pieces of information and to make it look more like a formatted date. So we're going to call that joined. And we're going to set it equal to. So when we call this, we're just going to allow them to put in numbers. So that's going to be an integer. But if we try to concatenate that like it's a string, we'll end up getting an error. So we need to convert it, these inputs that are coming in to strings. So we're going to use str function to do that. And so first we're doing the year, and then we're going to use the plus, and then in quotes, we're going to do a slash, and then another plus. Right? So we're converting that to a string and then concatenating it with another string. And then we'll do the month and the day after that using the same pattern. So we're going to do string month, and then plus, and then in quotes, a slash, and then another plus, and then string day. And then we're done with that line. So I'll hit return to go to the next line. And then I'm going to print out that. So I'm doing print joined. All right, so I'll run that cell. Again, nothing, there's no output, but then now that it exists, I can call it. So I can say print underscore date. And then, so in our sample, we're doing 1871, comma, and then 3, comma, 19. And the spacing is not actually that important right there, but just to make it clear, put it in space. And then so if I run this, it outputs my formatted date. Okay. So I'll give you a moment to do that. And if you have any questions or run into any issues, please put up a red sticky or raise your hand so we can get you some help. All right, so we'll move on to another example. And we're going to define something that takes an average of some input. So we're going to do def and just call it average. And we will take in something called values. And then we need our closing, or not our closing, but our ending colon. And then the body of our function. Okay, so we want to demonstrate here how we're able to return something from a function. functions always return something, even if it's that something is a thing called none. So, and we'll demonstrate that shortly. But first, we're going to check. So like when we're using the return keyword, we tend to use it. You can put it anywhere, but for clarity, it's a good idea to have returns in the beginning when you're doing sort of like error checking. And the so we'll see an example of that right now. So we're going to check using an if statement, and we will say if, and we're going to use the length function. So that's len, and we're going to feed it values. And we're going to say if the length function or the length of values is equal to 0. So we remember you use double equals because we're doing an exact check. And then we need our colon for the end of our to terminate that if. And then we're going to automatically return none. And we're doing that essentially manually, right? That we're returning a special thing called none, which is like a null or empty. All right. And then, so now I need to backspace once. So now I'm at the same level as the if. So that's like an error check. And then for normal operation, I'm going to return a calculation. And so I want to return the sum of values. So I'm using the sum function on the values. And then I'm dividing it by the length of values. So that's effectively going to give me the average, right? So len values. Okay. All right. So I'm going to run that so that it exists. It didn't give me an error. And so let's test it out. So in their example, they're saying A equals average, and we're taking the average of, and we're feeding it a list. So I need my square bracket, and it's 1, 2, 3. I'm sorry, 1, 3, 4. And then we close the square bracket, close the parentheses for our function call. And then we'll print that out. Print average is, and we need comma A. And let's try that out. And our average ends up being 2.6. But again, so the important idea here is that you have this keyword return, and you can use that to return something. So what if we did an empty list, right? So I'm going to take those out and run it. And you can see now average is none because I fed it an empty list. So this ended up being true, and it returned none. And then at the end, I returned the actual calculation. So that allows you to then again set up this where you have a variable name and you set it equal to a function call that returns something. And then you have that thing in your variable, and then you can operate on it and do more things with it. Okay, so to see that, in fact, that all functions return something, even if that something it just returns none. So we can use our print date to see that in action. So notice if we look back at our print date implementation, we never use the return keyword at all, right? So you would think, oh, well, it doesn't return anything. But again, it always returns something, and in this case, it will be that thing that is none. So we could do that by saying, let's see, so result equals print underscore date. And then I'm just going to do a random year and a random month and a random day. And then I'm going to, so again, that print function is going to print out the date, but I want to see what is in result. So I'll do print result is colon, comma, and then put in my result to print that out. And so let's run that and see what happens. So again, you see, even though there was no return statement in my print date function, it still did actually return something. And again, it was this magical object called none that it represents emptiness. And that's, again, it's like, okay, well, why is that important? Well, it's something you can check for sometimes to control for errors. All right, so before we move on, let's make sure that everyone is successful in making a function and calling that function. So again, we're going to pause here for a moment and ask if there are any questions. Okay, so let's take what we learned and then now see where, like, if we made a function, what would be a good way to then combine that with our knowledge that we learned about pandas? So to do that, I want you to, and so let's be sure that someone is moving this big chunk of code over. It is functions. So yeah, so I definitely don't want to type this out or have you type it out because it will take too long. Oh, it's the wrong one. There we go. All right. So I'll pause a moment so that they have a chance to copy that over. And then you're able to copy it over to yours. But we need to have this established. So I'll describe what it does. But again, you can see it would be pretty finicky to type that all out and have everyone not make any typos. So copy paste. And so what this does is so we have our function and it's called calculate life quartile. And so what it's going to do is it's going to take in information from a pandas data frame, and then we're going to apply this function to a column in it. And that column is going to have values that make sense for this. And so as an example, like there might be one where it's like it's 60, right? So then it's going to check, is 60 less than 58? No. So it's going to go down and it's going to find eventually one. And then if it doesn't find any, there's still an else that does none. But so we have a sample call here. We're passing in 62.5 and it outputs 2. And so you can see effectively that 62.5 is making this, it's passing this test, and then it returns 2. All right, so if we could get green check marks for people to let us know that you were able to get this code operational, and it spit out the two as an example. Hmm. All right, we have 11. So anyone needs any help, maybe put up a red. But if not, I'll probably start moving on. All right. So now we want to apply this function to a column in a data frame. So first I'm going to import my data. So I'm going to say data equals pd.read CSV, open parentheses. And then, so mine is actually right here, right next to it. So I could just use the file name, but I want to demonstrate a method that you can use to hopefully make it easier for you to get your paths in the future when you're not necessarily right next to it. So this is actually a folder on my desktop. So I'm going to actually go there the long way, even though I could just use the file name to show you how this can work. So my desktop folder is a special folder in my home folder. I mean, it's going to be the same on nearly every computer, right? So you're going to have your home directory when you log in, where it's going to keep everything associated with your user account. So I get my open quote for my file path. And then there's a ways to like do it from the root and like be really long, but you might end up with special folder names with spaces in them. So there's actually a nice little shortcut using the tilde, which is in the upper left-hand corner of your keyboard, and use Shift to get to it. And it's that little squiggly. So that's going to be a shorthand for your home directory. So it doesn't matter how much is underneath, like, not sure which way, like higher on the tree, it's going to take straight to your home folder. And then I'm going to hit the tab key, and then it should show the contents of my home folder. And you can see all the way at the bottom there's my desktop. So I could start typing desktop with a capital D. And again, capitalization is very important in your file paths. So, and then if I hit the tab key again, it's going to be like, oh, did you mean desktop? It can be like, yes. And you can see it changed tilde to /user/my username. And it like filled that in, right? And then I could keep doing the same thing. So I could hit the tab key and it's going to show me the contents of my desktop. And I want what's in my data folder. So I'm going to go there and I hit the tab key again, and it shows me then all those data files. So again, if you use that strategy to get to your unzipped folder with all your data, that might be an easier method. And for this one, I want to go to the all CSV. So I need that one specifically. So all. Hit return and then close quote. And I do need to set an index call, index underscore column equals and country. All right. And then, so we want to then, and I'm actually going to run that by itself. I know I got something, forgot a comma. Oh, yep, I forgot a comma. There we go. So now my data is loaded into that variable. And so I want to take and do Data, square bracket, life underscore quartile, and it's QRTL. And I'm going to set that equal to. Now this didn't exist before, so I'm creating that column by giving it a column name it hasn't seen before. And I'm setting it equal to data, square bracket, and I'm going to call on the column life exp, and it's with a capital E, underscore 1952. So I'm only working with that column in this case. And then I'm going to do dot apply, and that is a function. And then I'm going to give it the name of the function that we just ran up above. So that's calculate and underscore life underscore quartile. And notice it's not in parentheses. I'm sorry, it's in parentheses, but it's not in quotes. It's not like a string. And there's no parentheses for the function call, which is very unusual. But that's because this apply function is just taking the name of your function, and it knows that it only takes one thing, which is going to be the value of the cell, and it's going to feed the value of the cell to this function. And then we're going to end up with a column that has this function applied to every value in life expectancy 1952 column. So let's run that. Let's see, did I forget anything? I think so. So, and so what did I did not close the quote on my life expectancy. All right. So, all right. Now we have this new column. And so if we do, let's see, if I just do like data dot columns so we can see the list of names. So you can see it there. You should have, yep, you can see the last one here is this life quartile. And then, so if we copy paste, and you can see it's a column that has so we have our countries, which is our index, and then there's this column, and it just has values 1 through 4, depending upon the output of that function, based upon the input of the life expectancy in 1952. So let's graph that. And again, it's going to be too much finicky typing, but I'd like you to see an example of sort of like the full loop, and we can discuss it. So we'll have you grab it from the learner notes as soon as they copy it over. And then so we want this item. So once that's in the learner notes, you can copy it to your own notebook. But I'll go ahead and run it. See if I can get all the code. So what this did is it took our life quartile, and actually let me show you what is in value counts. So it might make more sense. This is this is what ended up getting stored in value counts. You can see it's the values 1 through 4, which is with the 4 possible outputs of our function. And then it has the count of, so it's 100 countries marked 1, and then you get all the way down to 4 countries for level 4. And so that's what we're then graphing down here. So by taking the value counts and sorting the index, that's why it's 1, 2, 3, 4, because we sorted the index. And then the value counts are these here, and it's based on this column. And then we're just using what we learned the other day, but we probably didn't cover this function for PLT. You can do a bar chart. And so for one axis, we're giving it the value counts index. So that's these numbers. And then for the y-axis, we're giving it the values. So that's these. And then the edge color black is just this, has a black edge on the default blue. And then we labeled it sum. But then you can see again, across the bottom, we have 1, 2, 3, 4, which was our X things that we fed to the bar chart. And then on the Y, we have the values that we fed in. All right, so I'll show you one more thing you can do. Because since now that we covered for loops and this question came up the other day, it's like, okay, well, I know there's 100 countries in one, but how do I know what 100 countries they are? So we can do that. Do a for loop, and we can just say for score, comma, and this might be new because we didn't do this earlier, I believe. So, but we can do score group. So we actually have 2 loop variables. And then they are going to get fed by in data dot group by, and we're grouping by life quartile column. And that needs to be in quotes. And again, we spelled it funny. Quartile. Close my group by, and we need the colon for the end of our opening for. And then we're going to do 3 lines of code. So we're going to do print, and we're going to say wealth score, colon, and that needs to be in quotes. Comma, and then we're going to do score, and then print, and we're going to do group dot index dot to list, to underscore list. And then close that, and then print, and then we're going to do a special string that's going to do basically a new line. So we're printing, and then in quotes, I'm doing \n, which is like a control sequence for a new line. So that way there'll be separators between these groups. All right, and let's try running that. And then, so again, this new line is just this blank space here. But you can see it printed out the wealth score, 1, 2, 3, 4, and then you have a list of all the items that are associated with that group. So we will pause there and let people make sure everyone is caught up and has any questions. Feel free to give them out. Okay. All right. there are no questions about what we covered, we'll spend some time on a.
Seems like a couple of us are getting key error life underscore QTRL.
Is that a Q or a G?
Should
Looks
be
like
a Q the way I did it. So, but as long as you're consistent, it will work because you're making.
Yeah.
So basically, at this point, you're creating it. So whatever you did here, you need to keep doing. And also, if you didn't run this line, that key won't exist, and then it won't work either. So if you ran this line, and then whatever you put in here, keep doing that. You get the. Okay. So we'll spend a few minutes on a couple of challenges. So, and these should be copied over to the Learn Notes. I think it's out of sequence though, so it's not where I expected it.
it's on the notes, Hamish.
Okay. And then we also do the encapsulation one that was right under it.
Sanjeet, are you free for a breakout room?
Yes.
I believe our next scheduled break is at 10:45. So we'll probably have you work on this challenge all the way up to then, and then we'll take the break, and then we'll talk about it after the break.
Sounds like a great plan. I'm gonna go ahead and pause recording then.
Through the challenges we just did. So the first one was based upon this function. So I ran this cell, so this function exists. And then if I call it using this syntax, what do I get? And so we end up getting what looks like a bit of gibberish. So more than likely, these numbers will be similar but different on your computer. And that's because that's just the memory location. So if you print the name of your function, what it outputs is the memory location of that function in your computer. And again, that's probably going to vary highly between our various computers. So it'll be a different number, but you'll be some arcane number. And then it just did this as well, because that was the other part of the print function. So this is to drive home that we always need to call our function with parentheses and feed the arguments directly to it in the parentheses. And you might be thinking of, well, we just saw an exception earlier today, and that's true, but let's first fix this, and then we'll talk about that exception. So what you would probably want to do most likely is you could just say print calling, and then you would use your function named report, and you would feed it the value. And so if we run this, we get probably more of what we were expecting when we wrote that original, or when that original call was written. That's probably what they were trying to go for, but then they did not call it correctly. So by correcting the call, you can get this output. So the one exception is that, or it may be seen in other instances, but when you have something like the apply function in pandas, because it is making the call for you. So you just give it the name, and so it goes and it looks up your function, and then it calls your function for you. So that's why you're able to use just the name in the apply function without using parentheses and arguments. It's because pandas will be using the location memory on your computer to then apply that code you wrote to a column. Is there any questions about that before we look at the second one? So for this one, we're importing pandas as PD. Well, you probably already had that imported, so you wouldn't need to do that again, but it won't hurt to do it again. And then we just want to have an argument that's going to take in our file name. Again, it is based upon the instructions in the let's just say file name. And then we're going to pd.read underscore CSV file name. And then we want to return, and it was data.min. So let me make sure I get this correct. 1 moment. And yeah, so yeah, we're just using the min function directly off our data frame. So we did some, you saw something similar earlier when Jeff was teaching, when he looped through and I think he output the min. But in this case, our function is just doing the one based upon the file name we would be feeding it. And so that's what you would do to do that solution of that challenge. So again, so we create a function that takes a single file name as an argument, loads the data in the file, and outputs the min for that entire data frame. Any questions about that one?
If you wanted to pass an index, could you do multiple? Would the index go in the call or the function?
The index in what sense? You mean like
In the when you're reading the file names?
well, in this case, this function we wrote only takes a single file name.
Okay.
We would have to design it differently if we wanted it to take like a list.
All right. And you couldn't put the list in the function, that would blow up, right?
So yeah, it would try to look for that entire list probably as the file name,
Okay.
and of course that path doesn't exist
All right.
as a single entity.